The National Electrical Code, or NEC, does not explicitly state a requirement for a service switch to be installed at counter height. However, local authorities having jurisdiction or often have the power to adopt local amendments or interpretations that may go beyond the NEC minimum requirements. Therefore, the local town's AHJ may have implemented a local amendment to the NEC mandating service switches at counter height. This type of amendment would typically be documented in the local building codes. The first step is to verify whether such an amendment exists by contacting the local AHJ directly. Even if a specific height requirement isn't explicitly stated, the AHJ might be referencing Article 110.26 of the NEC, which addresses accessible and operable electrical equipment. Article 110.26 states that, notwithstanding the other requirements of this code, raceways, fittings, and equipment shall be installed so that they are accessible for maintenance and operation, and so that the building occupants or facility operating personnel can safely and readily operate or maintain such equipment. The AHJ might interpret this to mean that a service switch at counter height is necessary for accessibility and safe operation by building occupants or facility personnel. Ultimately, the AHJ interpretation and enforcement holds significant weight in the local area. While an appeal of the AHJ decision is possible, compliance with their request is often the most practical approach. Therefore, confirm any local amendments with the AHJ and familiarize yourself with Article 110.26 regarding accessible and operable equipment. In Massachusetts, the enforcement of electrical codes falls under the purview of the Board of State Examiners of Electricians. They are responsible for adopting the Massachusetts Electrical Code, which is based on the NEC, with any state-specific amendments. Local AHJ, such as city or town electrical inspectors, enforce this code at the local level. These local inspectors have the authority to interpret the code and ensure compliance with both the state-adopted code and any local amendments. If a local AHJ red-tagged an installation for not having a service switch at counter height, they likely have a reason rooted in local regulations or their interpretation of the NEC general requirements for accessibility and safe operation. To resolve such a situation, firstly, request the specific code section or local amendment that the AHJ is citing. If it's a local amendment, obtain a copy of the local building code or regulation that outlines this requirement. Secondly, review Article 110.26 of the NEC, focusing on the requirements for accessibility and safe operation. Consider how the AHJ might be interpreting these requirements in the context of the specific installation. Thirdly, if the AHJ interpretation seems questionable or inconsistent with the NEC or local amendments, respectfully discuss your concerns with the AHJ. Explain your understanding of the code and ask for clarification on their interpretation. Fourthly, if the discussion with the AHJ does not resolve the issue, explore the possibility of appealing the decision. The process for appealing an AHJ decision typically involves submitting a written appeal to a higher authority, such as the local building department or a state-level board. The appeal should clearly state the reasons why you believe the AHJ decision is incorrect and provide supporting documentation, such as code references or expert opinions. Fifthly, if an appeal is not successful or not feasible, comply with the AHJ requirements to avoid further delays or penalties. This may involve relocating the service switch to counter height, even if you disagree with the requirement. The purpose of electrical codes is to ensure the safety of people and property. While the NEC provides a baseline for electrical installations, local AHJ have the authority to modify or interpret the code to address specific local conditions or concerns. These AHJ are typically city or county inspectors who are responsible for enforcing the electrical code within their jurisdiction. This means that the requirements for electrical installations can vary from one location to another, even within the same state. It is essential to understand the local electrical code requirements before beginning any electrical work. This can be done by contacting the local AHJ or by consulting with a qualified electrical contractor. The NEC is updated every 3 years, so it is important to use the latest edition of the code. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical installations, such as wiring methods, equipment, and special occupancies. Each article covers a specific topic within a chapter, such as grounding, overcurrent protection, and wiring methods for hazardous locations. Each section covers a specific requirement within an article, such as the size of conductors, the type of overcurrent protection, and the location of receptacles. The NEC also includes a number of tables and figures that provide additional information and guidance. These tables and figures are used to determine the size of conductors, the ampacity of conductors, the overcurrent protection for conductors, and the grounding requirements for equipment. Firstly, understand the scope of the NEC. The NEC covers the installation of electrical conductors, equipment, and raceways, signaling and communications conductors, equipment, and raceways, and optical fiber cables and raceways for the following, namely public and private premises, including buildings, structures, mobile homes, recreational vehicles, and floating buildings, yards, lots, parking lots, and industrial substations, installations of conductors and equipment that connect to the supply of electricity, installations used to export power from a generating source. Secondly, note what the NEC does not cover. The NEC does not cover installations in ships, watercraft other than floating buildings, railway rolling stock, aircraft or automotive vehicles, installations underground in mines, installations of communication equipment under the exclusive control of communication utilities located at doors or in building spaces used exclusively for such installations, installations under the exclusive control of an electric utility where such installations are located in legally established easements or rights of way. Thirdly, the NEC is not intended as a design specification or an instruction manual for untrained persons. It is intended to be used by qualified persons who are familiar with electrical theory, construction practices, and safety procedures. Fourthly, compliance with the NEC does not necessarily ensure a safe electrical installation. Electrical installations must also be designed and installed in accordance with accepted engineering practices. The NEC is a comprehensive set of rules and regulations that govern the installation of electrical systems. It is intended to protect people and property from electrical hazards. However, the NEC is not a substitute for good judgment and common sense. Electrical installations must be designed and installed in accordance with accepted engineering practices and safety procedures. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to use the latest edition of the NEC when designing and installing electrical systems. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical installations, such as wiring methods, equipment, and special occupancies. Each article covers a specific topic within a chapter, such as grounding, overcurrent protection, and wiring methods for hazardous locations. Each section covers a specific requirement within an article, such as the size of conductors, the type of overcurrent protection, and the location of receptacles. The NEC also includes a number of tables and figures that provide additional information and guidance. These tables and figures are used to determine the size of conductors, the ampacity of conductors, the overcurrent protection for conductors, and the grounding requirements for equipment. Firstly, Article 90.1 Purpose of the NEC states that the purpose of this code is the practical safeguarding of persons and property from hazards arising from the use of electricity. Secondly, Article 90.2 Scope specifies what the NEC covers, including electrical conductors, equipment, and raceways, signaling and communications conductors, equipment, and raceways, and optical fiber cables and raceways. Thirdly, Article 90.3 Arrangement states that the NEC is divided into chapters, articles, and sections. Chapters are broad categories, articles are specific subjects within a chapter, and sections are specific requirements within an article. Fourthly, Article 90.4 Enforcement states that the NEC is intended to be used by qualified persons and is not intended as a design specification or an instruction manual for untrained persons. Fifthly, Article 90.5 Mandatory Rules and Explanatory Material explains the use of mandatory rules, which are characterized by the use of the word shall, and explanatory material, which is in the form of fine print notes, informational notes, and annexes. The term authority having jurisdiction, or OJ, is defined in Article 100 definitions as an organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. The AHA may be a federal, state, local, or other regional department or individual, such as a building official, electrical inspector, fire marshal, or insurance company representative. The AHA is responsible for interpreting the requirements of the NEC and for determining whether an electrical installation complies with those requirements. The AHA has the authority to approve or disapprove electrical installations and to order corrections to be made to non-compliant installations. The AHA also has the authority to issue permits for electrical work and to conduct inspections of electrical installations. The AHA is an important part of the electrical safety system. The AHA ensures that electrical installations are safe and comply with the requirements of the NEC. Article 110 provides general requirements for electrical installations. It covers topics such as wiring methods, overcurrent protection, grounding, and equipment. Article 110.2 approval requires that all electrical equipment be approved for the intended use. Approval is typically indicated by a listing mark from a recognized testing laboratory, such as Underwriters Laboratories, or UL. Article 110.3 examination, installation, and use of equipment requires that electrical equipment be installed and used in accordance with the manufacturer's instructions. This includes following the manufacturer's recommendations for the proper wiring, grounding, and overcurrent protection of the equipment. Article 110.14 electrical connections requires that electrical connections be made in a manner that ensures a good electrical connection and prevents overheating. This includes using the proper connectors, tightening connections to the proper torque, and protecting connections from corrosion. Article 110.16 arc flash hazard warning requires that electrical equipment that is likely to require examination, adjustment, servicing, or maintenance while energized be marked with a warning label that identifies the arc flash hazard. The warning label must include the nominal voltage, the arc flash boundary, and the level of personal protective equipment, or PPE, required. Article 110.26 spaces about electrical equipment provides requirements for the working space around electrical equipment. The working space must be large enough to allow workers to safely access and maintain the equipment. The working space must also be clear of obstructions and must be properly illuminated. Article 110.31 enclosure types provides requirements for the types of enclosures that are used to protect electrical equipment. Enclosures must be suitable for the environment in which they are installed. For example, enclosures that are installed in wet locations must be watertight. It is essential to consult the specific requirements of the NEC and local amendments to ensure compliance with electrical codes and regulations.